Welcome to the .NET MAUI interview series. Let us start with the first question. What is .NET MAUI? .NET MAUI stands for .NET Multi-Platform App UI. It is a cross-platform framework developed by Microsoft that allows developers to create native mobile and desktop apps using a single code base. With the .NET MAUI, you can target Android, iOS, macOS, and Windows platforms, all using C# and XAML. It is the evolution of Xamarin Forms and part of the modern .NET ecosystem, fully integrated with the .NET 6 and later versions. This unified approach simplifies development, reduces code duplication, and makes cross platform app development more efficient and maintainable. Now, let us look at the difference between .NET MAUI and Xamarin Forms. First, .NET MAUI introduces a single project structure. Unlike Xamarin Forms, where each platform had a separate project, .NET MAUI unifies them into one, making development and maintenance much easier. Second, .NET MAUI is built on .NET 6 and later, while Xamarin Forms was based on older .NET versions or Mono. UI in .NET MAUI is also more powerful with better native integration and performance. Platform-specific code is cleaner in MAUI using partial classes and multi-targeting, replacing Xamarin's dependency service approach. Lastly, .NET MAUI offers improved performance with better app startup time and responsiveness thanks to the latest .NET runtime enhancements. In this question, we explore the main components of a .NET MAUI application. The first key component is app.xml and its code behind file app.xml.cs, which define the application's lifecycle and shared resources like styles. Next is the main page.xml, which acts as the default page when the app loads. It uses XML to design the UI and a code behind file for logic. The platforms folder holds platform specific files such as launchers, permissions, and platform specific code. The resources folder is used for managing images, fonts, styles, and raw assets needed across the app. One of the most important files is movieprogram.cs, where you configure the app, register services, and set up dependency injection. Finally, while not mandatory, the views and models folders are commonly used to follow the MVVM pattern, more clean and maintainable architecture. Let us understand the role of movieprogram.cs in a .NET Movie application. This file is the entry point where your app is configured before it runs. Inside the create movie app method, we use movie app.create builder to set up essential services. Here, we register the main app class, configure fonts, set up dependency injection, and include any third-party libraries. If you are using services like HTTP clients, SQLite, or custom handlers, this is the place to register them. Once everything is configured, the build method returns the final movie app instance that powers your application. In short, movieprogram.cs is like the startup file of the app, making sure everything is wired up properly before your UI appears. One of the most powerful features of .NET MOVI is its single project structure. Unlike Xamarin Forms, where each platform had its own project file, .NET MOVI combines everything into a single unified project. You write your UI and business logic once and use the platforms folder for any platform specific implementations like notifications or permissions. The resources folder is where you manage shared images, fonts, raw assets, and styles. This approach makes it easier to maintain your app, reduce redundancy, and improves the overall developer experience. It also simplifies the build and deployment process by managing everything in one project. In .NET MOVI, navigation between pages can be done in two main ways: traditional navigation and shell navigation. With traditional navigation, you wrap your pages inside a navigation page, then use push async to navigate forward and pop async to back. For example, to navigate to a page named second page, you use await navigation dot push async of new second page. However, the preferred approach in .NET MOVI is shell navigation. Shell simplifies navigation using root names and URI like syntax. You first register your roots in appshell.xml and then use await shell.current.go to async of second page. Shell also supports advanced scenarios like query parameters and deep linking. In summary, Shell provides a modern, flexible, and scalable way to navigate in .NET MOVI apps. .NET MOVI Shell is a powerful feature designed to simplify the structure and navigation of your app. Shell acts as a container that helps organize your app's pages using flyout menus, tabs, and navigation routes. It supports URI based navigation, which makes page transition simpler and more consistent. You can use routes like await shell.current.go to async of details. Shell also supports advanced capabilities like deep linking and query parameters, which are useful and helpful when passing data between pages. You define the navigation structure and routes in appshell.xml, which becomes the root of your app's UI. Shell is especially useful when your app has a complex UI or needs scalable navigation patterns. In .NET MOUI, there are multiple ways to pass data between pages. The first method is using constructor parameters. When navigating to a new page, you can pass data like await navigation dot push async of new second page of data. Then receive it in the constructor of second page. The second and more modern way is using shell query parameters. You append data to the root like await shell.current.go to async of second page question mark message equal hello. On the receiving page, use the query property attribute to bind the parameter to a property. Query property of name of message. The third method is to use shared services like a singleton view model or a data service. This is useful when passing complex objects or across multiple pages. These flexible methods help maintain clean and scalable architecture in your MOUI apps. MVVM stands for Model View Model, a design pattern widely used in .NET MOUI. The model represents your data or business logic like a class for products or customers. The view is your XML page where you design the user interface. The view model acts as a middle layer. It exposes properties and commands that the view can bind to. With the binding, you can update the UI automatically when data changes. For example, label text equal binding title, and with commands, you handle user actions like button clicks using button command equal binding save command. MVVM helps keep your code clean, testable, and scalable, making it a core architecture for MOUI apps. Data binding is a powerful feature in .NET MOUI that links your UI elements to properties in your view model. When a view model implements iNotify property changed, the UI automatically updates when the bound data changes. There are several binding modes. One way, data flows from the view model to the view, great for labels and display elements. Two-way allows changes in the UI to reflect back into the view model, commonly used for form fields like text entries. One time, data is set once and does not update again. You set the binding source using the binding context. For example, entry text equal binding name. Behind the scenes, the name property lives in the view model and can change dynamically while keeping the UI in sync. This mechanism helps create responsive, interactive UIs without writing repetitive code. In .NET MOVI, platform-specific code is handled in a few key ways. The Platforms folder holds platform-specific files, allowing you to implement logic tailored to specific operating systems like Android, iOS, or macOS. You can also use conditional compilation with the hash if directives to include platform specific codes. For example, if it is Android specific. If it is iOS/iOS specific code, like that. For a more complex platform specific features, dependency injection helps you abstract platform dependent functionality through interfaces and platform specific implementations, keeping your code clean and maintainable. This way, you can ensure your app takes full advantage of each platform's capabilities without cluttering your core logic. .NET MOVI includes a rich set of built-in controls to create beautiful and functional UIs across platforms. Here are some of the most commonly used controls. Label for displaying text, entry for single line text in input fields, editor for multi-line input like comments or descriptions, button to trigger actions when tapped, image to show pictures or icons, collection view or list view for displaying list of items such as product list or chat messages, switch to toggle between true or false states, slider to pick a numeric value within a range, date picker and time picker to let users choose dates and times, picker to present a drop down style selection list. These controls, combined with powerful layout containers like stack layout, grid, and flex layout, make building responsive and interactive interfaces easy in .NET MOVI. Collection view is a powerful control in .NET MOVI used to display a list or grid of items. It is more efficient and customizable compared to the older list view. With the collection view, you can arrange items vertically, horizontally, or in a grid layout using the items layout property. You can bind it to a list of data using items source and use data template to define how each item should appear. For example, a product list can display a name and image using a simple stack layout. It also supports item selection, multi selection, and item tapping events, making it a great choice for dynamic UI lists like product catalogs, new feeds, or contact list. In .NET Movie, when using shell, navigation becomes structured and easy to manage. First, you define routes in appshell.xml using the root property. Shell content root equal details, content template equal data template, local details page. Then navigation between pages using the go to async method. Await shell.current.go to async of details. You can also pass data using query parameters. Await shell.current.go to async of details question mark name equal John. On the destination page, you use the query property attribute to receive the parameters. Shell supports both stack-based navigation and model pages, making it flexible for various app flows like master detail, tabs, or deep linking. Both the list view and collection view are used to display list of items in .NET Movie, but collection view is the modern recommended option. Here are the key differences. Performance. Collection view is more efficient with better virtualization and less memory usage. Layout flexibility. List view only supports vertical layout while collection view supports vertical, horizontal, and even grid layouts. Selection. Collection view supports both single and multiple item selection, whereas list view only supports single selection. Grouping and refreshing. Both support grouping and refresh view, but collection view makes implementation simpler and faster. Since list view is considered legacy, it's recommended to use collection view in all new .NET Movie apps. In .NET Movie, you can pass data between pages in two common ways. First, using constructor. Await navigation dot push async of new details page of item. Here, you simply create the new page and pass the data directly. Second, with the shell navigation, you can use query parameters. Shell dot current dot go to async of dollar details question mark name equal John and age equal 30 on the receiving page. Use the query property attribute to map parameters to properties. Query property of name public string name get set. This is especially useful in MVVM architecture, where you want to keep your navigation and view model interactions clean. In .NET MOVI, the MVVM pattern, model, view, view model, is the recommended way to structure apps. The model holds your data and business rules. The view is your XAML layout. View model acts as a bridge, exposing data and commands to the view. You set the view model as the binding context of the view, which allows data binding. To update the UI automatically, your view model must implement iNotify property changed. Instead of handling button clicks in code behind, you define iCommand properties to the view model. These are bound to the UI and help maintain a clean separation of concerns. MVVM makes your code more maintainable, testable, and organized, especially in larger applications. In the MVVM pattern of .NET MOVI, the iNotify property changed interface plays a vital role in keeping the user interface in sync with the data. It allows your view model to notify the view when a property's value changes. This ensures that any data bound UI elements update automatically without manual refreshes. To use it, your view model class implements iNotify property changed, and each property that needs to be bound raises the property changed event in its setter. This is essential for dynamic UIs where user actions or background operations update data on the screen. Without it, the bindings would not reflect the latest values, breaking the MVVM flow. To handle button clicks in MVVM style, .NET MOVI uses commands. In your view model, define an iCommand property and initialize it with a command object that points to a method. This method holds the logic you want to execute when the button is clicked. For example, submit command equal new command of on submit. Then in your XAML view, bind the button's command property. Button text equal submit command equal binding submit command. Make sure your view model is assigned to the page's binding context. Now, when the user clicks the button, the command in the view model gets executed, keeping everything clean and separated. In .NET MOVI, dependency injection is built in and allows you to pass services or components into your classes rather than creating them manually. This makes your code easier to test, reuse, and maintain. To use DI, register your services in movieprogram.cs. Builder.services.add singleton of I my service. Then inject them into your view model via constructor public my view model of my service. You can also retrieve services using the built-in service locator app.current.services.getService of my view model. This approach encourages loose coupling and helps manage dependencies across your app in a clean, modular way.